Hey guys, I want to start a new series where I kind of do one quant finance interview question every day and explain it to you guys. So today's day one. Um, Here's the question. 14 pieces of paper labeled 1 through 14 are placed in a line at random. Spot i's local maximum if the paper at the ith position is strictly larger than all the adjacent papers. Find the expected number of local maxima in this sequence. For example, with six numbers, you have 5, 1, 3, 2, 4, 6. And this sequence has three local maxima at the first, third, and last spot. So the first spot, 5, is bigger than 1, so that makes 5 a local maximum. The third spot, 3, is bigger than both 1 and 2, so that also makes it local maxima. And the last spot, 6, is bigger than 4, so in total we have 5, 3, 6 as the local maxima for the sequence, and therefore the sequence has 3 local maxima. I highly recommend you guys to pause the video to think about this question yourself, as I'm going to explain the solution in a bit. Hey, welcome back to the solutions. So just by looking at the sequence, we can kind of identify two different types of positions. And the first type would be the endpoints. So this will either be position 1 or position 14. And the rest of them will just be interior points. So that's position 2 through position 13. And the benefit of doing this is by classifying into two different categories, we can find the probability of each category and then add them up at the end. And that's going to give you our final answer. So the first category for the endpoints. The endpoints are easy to analyze because they only have one adjacent number. So in order for, say, position number 1 to be our local maximum, it just needs to be bigger than position number 2. So what's the probability of that? And it's pretty intuitive because position number 1 can either be bigger or smaller than the second position. So it'd just be 50% or 1/2. And that's our probability for the endpoints to be the local maximum. For the interior points, however, each of the interior points have two adjacent numbers. And we have to think, okay, what's the probability for the middle number to be bigger than its adjacent numbers? And for probability problems, we can always start thinking about, okay, how many cases we can arrange three different numbers into three positions. And we know the answer to that would be 3 times 2 times 1, which is 3 factorial, which is 6. So we have 6 total cases where you can arrange three different numbers into three different positions. And out of these 6 numbers, we just want to find the cases where the middle number will be bigger than its adjacent numbers. And we know intuitively we're going to have 2 cases we're going to have that. Because, say, the middle number is 3, and we can either have 2 and 1, or we can have 1 and 2. We're going to swap the adjacent numbers, and that gave you 2 cases where the middle number will be bigger than adjacent numbers. So the total probability for interior points to be a local maximum will be 2 over 6, or 1/3. So our final step, all we have to do is just to add up the probabilities and find the expected value. And we know the expected value for something to happen, which is be the probability of that thing happening and how many times that thing will happen. And then we just got add everything up. So for the endpoints, how many endpoints are there? There can only be 2 endpoints. So the number of occurrences of endpoints would just be 2. And probability of endpoints to be local maximum, as we can find here, would just be 1/2. And then we can just add the same thing for interior points. There are 12 interior points, and then the probability of interior points to be local maximum will be 1/3. So our final answer will just be 1 plus 4, which is 5. And 5 is our final answer to this problem. It'll just be 5. Yeah, that concludes our day one of doing one quant finance question every day. If you enjoyed the video, please drop a follow and come back tomorrow. Thank you.